So to conclude our examples for proofs by contrapositive, let's go ahead and consider the following example. So for this example right here, basically what we are trying to do is make our own addition to Rosen's table back in Rosen section 1.6. What we want to do is show that this right here is a valid argument. So putting everything together, we recall to show that something is a valid argument, we take our hypothesis and we want to show that that implies our conclusion. So what we're really trying to show is this nice big expression. We want to show not R implies, P implies not Q, implies P implies Q implies R. And the whole reason why I picked this as an example is because it has many different implications in it. And so we have to be very careful when we do our proof technique to be able to make sure that we're applying our different proof techniques correctly and at the right points. So let's go ahead and prove this. So my very first implication that I have is this middle one, this middle implication. So I have a hypothesis on this left-hand side. So this is my hypothesis. And this is my conclusion. So for our very first step, we want to show if this hypothesis, then this conclusion. So I'm going to do that in a direct proof fashion. So we'll do a direct proof. In a direct proof here, I assume that my hypothesis is true. So I assumed that my hypothesis is true, and what I want to show is that my conclusion is true. I want to show that P implies Q implies R is true. Well, this expression here is another implication. That means I'm going to have to apply another proof technique here to be able to prove this expression right here is true. So I am now looking at this expression, and I see that I have this P as my hypothesis. And I have Q implies R as my conclusion. So now I'm focusing just in on this statement, and I want to show that it's true. So here again, I'm going to use a direct proof technique, and I'm going to assume my hypothesis and try to show that my conclusion is true. So I'm going to indent this a little bit just to show that I am now concentrating on this part of my proof only. So now, using a direct proof to prove this particular expression, this particular implication, I want to assume that P is true, and I want to show that Q implies R is true. Well, here again, we have another implication. So we're going to have to apply another proof technique to try to show that this is a true statement. So I could try another direct proof technique. I would be assuming my hypothesis here. My hypothesis is Q, and my conclusion is R. And if I assumed Q and I wanted to show R, well, unfortunately, nothing that I've talked about so far said anything about the truth value of either Q or R. So direct proof of this particular implication would be a little bit difficult. So instead, I'm going to do a proof by contrapositive of this implication here. Once again, indent it to show that I'm focusing just on this implication. So I'm doing a proof by contrapositive of just this implication, Q implies R. So a proof by contrapositive, that means that we are going to assume not R, and we want to show not Q. Right? I took the contrapositive of this statement. Not R implies not Q. Then you assume not R, I want to show not Q. Well, why in the world does this help us? Well, it helps us because way back up at the top, I had assumed an implication right here that involved R. So we were given or rather we assumed right here that this big ol' implication was true. So we were given that this thing, we assumed that this thing was true, and we also assumed that P was true. So this P is true. And in this part of the proof, we assumed that not R is true. So we have true implies something is a true statement. Well, this implication right here, this is a true implies something. So the only way that this thing is going to be able to be true, and you can write down a truth table and try all the values of P, Q, and R to verify that this is the case, is that we would need that this must be true. Since I'm running out of room, I won't be able to do that truth table on the side, but you can go ahead and do it and verify that yes, indeed, not Q must be true. Hence, not Q is true. And then all I have to do is sort of walk backwards from my argument to be able to conclude my proof. I know that not Q is true. Well, that's what I was trying to show to verify that this thing was true. And that's what I wanted to show to verify that this thing was true. And that's what I wanted to show to verify that this thing was true. So by stepping backwards through my different proofs by contrapositive and a direct proof and a direct proof, I've been able to unwind this very complicated expression with a lot of different implications to be able to show that it indeed is true. So I wanted to give you this example here because whenever you see multiple implications, you will going to have to use multiple different proof techniques to prove each of those individual implications, and you might have to use different proof techniques there.